Hey guys, it's Ms. Miklos, and today we're starting chapter 5. And so there is a note handout that pretty much covers all the sections for this chapter. And on this front sheet, you're going to see that there are a massive amount of things to memorize. And I put them all here in one place just so you can have something to go off of. Today, we are specifically going to be talking about the reciprocal identities and the Pythagorean identities, and these are actually things that you guys have learned previously. So let's start with all of the identity relationships. So the first, as we said, are the reciprocal identities. We have previously learned that sine and cosecant are reciprocals of one another. So we know reciprocal is when we flip the fraction, so the numerator becomes the denominator, and the denominator becomes the numerator. Another way of thinking about that is dividing 1 by whatever the value is. So for example, since sine and cosecant are reciprocals, sine of theta is equal to 1 over cosecant theta, and cosecant theta is equal to 1 over sine theta. I want to point out here that we always are putting angles after our trig function. Okay, a trig function does not exist if it doesn't have an angle afterwards. I know that cosine and secant are reciprocals of each other, so cosine of theta is equal to 1 over secant theta, and secant theta is equal to 1 over cosine theta. And tan and cotangent are our last set, so tan theta is equal to 1 over cotangent theta, and cotangent of theta is equal to 1 over tan theta. Okay, so we already know these 6, we're just writing them in a different way. The last two that we're going to talk about are sine and cosine, and I'm going to zoom in here. Okay, and if we actually think about it, okay, sine we know is opposite over hypotenuse, and cosine is adjacent over hypotenuse. And if I go ahead and multiply by the reciprocal, notice my hypotenuses cancel out, and I'm left with opposite over adjacent, which is tangent. Okay, so we know that tangent is sine over cosine. Likewise, the reciprocal of tangent, cotangent, is equal to the reciprocal of sine over cosine, which would be cosine over sine. So these are the first 8 identities you guys need to have memorized. I would definitely expect to have a quiz on this. You need to know these. Now we're transitioning back to our unit circle. Okay, and last chapter we used this a lot, and we said that an ordered pair, sine was the y value and cosine was the x value. And what I'm going to go ahead and do here is actually make a right triangle. Okay, we know the hypotenuse is 1, and since this ordered pair is cosine sine, that means I'm going to the right cosine, and I'm going up sine. And since we have a right triangle, I can actually use this to go ahead and use the Pythagorean theorem. So my very first Pythagorean identity is sine squared plus cosine squared is equal to 1 squared, or just 1. So some of you guys may have wondered all of last year, where did this equation come from? And it actually comes from the unit circle, which we are familiar with. Some things that I want to point out quickly here. We have already talked about the fact that whenever I have a trig function, I need to have an angle afterwards. In the case when I have something squared, notice our squared goes between my trig function and my angle. This is telling me that we're squaring sine and we're not squaring the angle. So we always need to write any exponent immediately following that trig function. Okay, so our next Pythagorean identity, what I'm going to do is I'm going to divide everything by sine squared. So let's just think about this for a moment. Sine squared divided by sine squared would give me 1. Cosine squared divided by sine squared. That kind of sounds like cosine over sine. Just instead of cotangent, we are going to write cotangent squared. And lastly, okay, 1 divided by sine squared. if I look, 1 divided by sine is cosecant. So I'm going to go ahead and write cosecant squared. Now, theta, we know just represents the angle. We could see a bunch of different variables there. It might be alpha, it could be x, okay? I'm just choosing to use theta in this particular instance. The second thing we can do with this equation is to divide everything by cosine squared. Sine squared divided by cosine squared gives us tan squared. So I'm going to go ahead and write tan squared. Cosine squared divided by cosine squared gives us 1. 1 divided by cosine squared gives us secant squared. So tan squared plus 1 is equal to secant squared. So you have a few options. You can definitely just memorize these 3 identities. You can also just memorize this first one and learn how to derive the other 2. It's really up to you, but bottom line, okay, we need to have these 11 identities memorized. And you guys could kind of see from the front page, there's a lot of memorization this chapter. The good news is all of it is stuff that we did last year in Algebra 2 Trig. Okay, but that doesn't necessarily mean it's easy. So I would advise memorize the formulas or identities we need every single day. So that way you're not waiting until the last minute to memorize a ton of stuff. So now we're going to get into the fun stuff. And I am being serious. This is actually one of my favorite things to do in this class because to me it's kind of like a puzzle where you're trying to find things that fit, and you're trying to simplify it in a special way. So when it says simplify, what that really means to us is that we want to have our expression in the least amount of terms possible. So that means that I want to have it so there are no fractions. There's a bunch of different strategies, okay, and some strategies I've written down here for you, and I'm going to go ahead and list them in the order that I normally look for stuff. The first thing I always look for are the Pythagorean identities. Okay, so that would be if I see that I have something squared, I see a binomial that has something squared in it or 1 in it, okay, because often I can use that to help me simplify the expression. The second thing I normally do is use other math strategies to help us simplify. So that might be factoring, it might be adding fractions by getting a common denominator, etc. So a lot of our previous math that we've learned is going to come into play in this particular lesson. When all else fails, the final thing I do is try and rewrite everything in terms of sine and cosine. And the reason why we do this is because all 6 of our trig functions can be written in terms of those 2 values. And that's going to help us be able to simplify and make it into a single term. Now, the thing that I want to stress as we go through this is that there is more than one correct way to do a problem. And often in our notes here, I might actually show you more than one method. And the good news is, if we choose a correct path, we will get there regardless of how we choose to do it. We just need to make sure that mathematically we are using correct values and correct quantities. So looking at number 1, I'm going to go ahead and do this in 2 different ways. The first way that I would do it is, I know the first thing I'm always looking for is a Pythagorean identity, and I see this sine squared plus cosine squared. I know sine squared plus cosine squared is equal to 1. So what I'm going to do, I'm going to replace sine squared plus cosine squared with 1, and I get 1 over sine squared. Now I know I'm not done yet because I have a fraction. My advice to you guys is while we're going through this video, I would go ahead and have all the identities out if you don't have them memorized yet. Because the better we know those identities, the easier what the steps I'm doing are going to be. I know that 1 over sine is equal to cosecant, so 1 over sine squared is going to be equal to cosecant squared. Okay, another way that I could go about doing this, and I'm just going to show you I get the same exact answer, is I know mathematically when I divide a binomial by a monomial, that just means that I'm dividing each term in the numerator by whatever is in the denominator. So I'm going to go ahead and write this as sine squared over sine squared plus cosine squared over sine squared. So I get 1 plus cosine squared divided by sine squared is cotangent squared. I know that 1 plus cotangent squared is one of our Pythagorean identities, and it is equal to cosecant squared. So even though this is the method I would use, I just want to show us that mathematically, if I'm doing things correct and I'm using the correct identities, we still get to the same answer. Number 2, I think number 2 is one of the toughest ones that we're going to go through. The reason being, I see this 1 plus sine, and that's not quite sine squared. It kind of looks like our Pythagorean identity, but it's not. Okay, I also see cosine squared, so what I'm going to do over here, I'm just going to remind us that sine squared plus cosine squared is equal to 1. So that means if I subtracted sine squared from both sides, I would get that cosine squared is 1 minus sine squared. So I'm going to go ahead and substitute that in for cosine squared. Now, the only reason that I would think to possibly do that is I notice that I have 1 plus sine in my denominator, and I'm thinking getting things in terms of 1 and sine could eventually help me. In fact, I know 1 minus sine squared is factorable. It is one of our difference of squares, so it becomes 1 plus sine times 1 minus sine over 1 plus sine. And all of a sudden, something really nice has happened, and these 1 plus sines cancel out, and I am left with 1 minus sine. This is my final answer. There's nothing else that I can do with it. The other way that I could go about doing this problem, okay, I'm going to go ahead and rewrite out the original problem here, is in just thinking, okay, 1 plus sine, that is almost like 1 minus sine squared. It's close, not quite. In order to get it to be 1 minus sine squared, I would have to multiply by 1 minus sine over 1 minus sine. Now mathematically, I know that I can do this because it is an expression. So all I'm really doing here is multiplying by 1. So when I do this, I would get cosine squared times 1 minus sine. When I FOIL that denominator, I get 1 minus sine squared. Now, I know that 1 minus sine squared is really, and I don't know why the heck I wrote equals there, is really cosine squared. So I'm replacing that 1 minus sine squared with cosine squared. Those cosine squareds cancel out, and I am left with 1 minus sine theta. Okay, so once again, you guys obviously just need to choose one way. This way is definitely quicker, but I just wanted to demonstrate once again that if we're using things that are mathematically correct, it should lead us to the same answer. Looking at number 3, I notice that I have a quantity that is squared. And there's really nothing that I can do inside that quantity, so I'm going to go ahead and square this. I know squaring a binomial just means that I'm multiplying it by itself. And then we're going to go ahead and FOIL. So I know that sine times sine is sine squared. Sine times cosine is sine cosine. Cosine times sine is cosine sine. And cosine times cosine is cosine squared. So if we're looking at this, the first thing that I notice is that I have sine squared plus cosine squared. We know that that is equal to 1 based on our Pythagorean identity. I also notice I have sine cosine plus cosine sine. Even though those don't look the same, I know that cosine sine could be written as sine cosine because of the multiplication. We know multiplication is commutative, so the order can change. So when I add these together, it becomes 2 sine cosine. There's nothing else we can do here, so that would be my final answer. Okay, looking at number 4, at first glance, it doesn't really look like there's much I can do right away. I don't have a GCF to factor out. It does not look like I have any Pythagorean identities going on. And I don't have fractions, so I can't get a common denominator. So what I'm going to do is write everything in terms of sine and cosine. So I know cotangent is cosine over sine. Cosine is already written in terms of sine and cosine, and cosecant is 1 over sine. I just want to remind us I should be writing an angle after every single trig function. The reason why I'm using theta here is because theta was in my original problem. On number 3, I use x because x was in our original problem. Okay, so I have cosine squared over sine minus 1 over sine. Now, it looks to me like we have a common denominator, so I can add these together, and I get cosine squared minus 1 over sine of theta. Now, this clearly does not look simplified to me, and I notice a cosine squared and a 1, and that makes me think of sine squared plus cosine squared equals 1. And I'm going to look and see, is there a way that I can get one of the sides of this equation to say cosine squared minus 1? And I'm thinking what we could do is first go ahead and subtract the 1. And then I could go ahead and subtract sine squared from both sides. So I notice that this is equal to negative sine squared. Now, when I'm simplifying negative sine squared over sine, that's like if I had negative x squared over x. I know that our squared cancels out with that sine, and I'm left with negative sine as my final answer. Looking at number 5, tan to the 4th plus 2 tan squared plus 1, this 4th power really freaks me out. And so mathematically, it's a good idea to factor whenever we have an exponent higher than 2. So I'm going to go ahead and try and factor this. I know that tan squared times tan squared would get me tan to the 4th. 1 times 1 gets me 1, and if I check my inside and outside terms, tan squared plus tan squared is 2 tan squared. Now, this looks similar to me. It kind of looks like our Pythagorean identity, where tan squared plus 1 was equal to secant squared. So I have secant squared times secant squared, which would be secant to the 4th power, because I know when I'm multiplying things, I add their exponents together. Number 6. I don't see any Pythagorean identities. It doesn't look like there are any mathematical things that we could do, like factor or multiply or anything like that. So I'm going to get everything in terms of sine and cosine. So I know cotangent is cosine over sine. So what I really have here is sine plus cosine squared over sine. Now, I know that I need a common denominator, and my common denominator here would be sine. So I'm going to multiply by sine over sine, and I get sine squared over sine plus cosine squared over sine. And now that I have a common denominator, I can combine these into a single fraction, sine squared plus cosine squared over sine. We know sine squared plus cosine squared is 1, and 1 over sine is cosecant. Okay, so this is definitely one of those things, the more we practice this, the better we get, because it becomes easier to think in this manner. I would also highly suggest that you guys leave your notes out while you're working on your homework, because a lot of the problems in the homework use similar strategies to go ahead and factor. Okay, number 7, and let's be honest, number 7 looks pretty awful. I'm going to go step by step. I'm going to start here by foiling out 1 plus sine squared, the quantity 1 plus sine squared, and I would get 1 plus 2 sine plus sine squared. And I'm actually not going to touch the denominator at all. The reason being, I'm curious if something is going to eventually factor out. Now, if I get to a point where I realize nothing's going to factor out, then I would have to distribute. The other thing that I noticed here is I have cosine squared plus sine squared, which we know is 1. So I have 1, and the reason why we can do that, even though we have parentheses here, is because I know the associative property allows me to change whatever's in a parenthesis. So I get 1 plus 2 sine over cosine times 1 plus sine. So we're definitely making some progress here. In that numerator, I notice that this can become 2 plus 2 sine. And I'm still holding out hope here that we can factor it. And if I have 2 plus 2 sine, I notice I have a GCF of 2, and I am left with 1 plus sine. And I'm getting really happy here because I notice that I have a 1 plus sine in the numerator and in the denominator, so I can cancel those out. So I have 2 over cosine. I know that cannot be my final answer, so I need to think. 1 over cosine is equal to secant, so my answer is 2 secant x. Wow, we did a lot there. Okay, and I promise you guys, in our examples today, we're going through some difficult ones. It's not one of those days where it's like, oh yay, I get all the notes, they're super easy, and then I get to the examples and they're really hard. In fact, you guys will find that, yes, some of the homework is going to be this difficult, but some of the homework is going to be easier than this. Number 8, I noticed right away that we have a cube, and we kind of said earlier, whenever I have an exponent higher than 2, I'm going to factor. And so you guys may need to remember, back in Algebra 2, we learned whenever we have 4 terms, we factor by grouping. And my guess is you guys really haven't used that a ton since Algebra 2. So just to review, what that means is I'm grouping my first 2 terms together and I'm grouping my second 2 terms together. In my first group, I notice I have a GCF of cosecant squared. When I take that out, I'm left with cosecant minus 1. If I want to double check, cosecant squared times cosecant is cosecant cubed. Cosecant squared times negative 1 is negative cosecant squared. In my second group, I'm going to factor out a negative sign, and I'm left with cosecant minus 1. Now, what I notice here is that I have a cosecant minus 1 in both of our terms. So I'm going to go ahead and factor that out. And I'm left with cosecant squared. And when I factor cosecant minus 1 out of this term, I'm left with minus 1. Now, off to the side here, I remember 1 plus cotangent squared is cosecant squared. So I get cotangent squared is equal to cosecant squared minus 1. So I'm going to say that this is cosecant minus 1 times cotangent squared. And I could keep on going and see if I can simplify this any further, but the sad news is we're not going to be able to. So this is actually going to be my final answer. So as you guys can see, not only do we need to know this new material, but we definitely need to remember the stuff that we learned back in Algebra 2 and earlier this year in pre-calculus. And our final example of the day here, tan minus secant squared over tan. Okay, once again, there's probably a few different ways we could go about doing this. The first thing that I would do is try and get a common denominator. So I'm going to multiply by tan over tan. So I get tan squared minus secant squared over tan. And I went ahead and kind of did two things at once there. I simplified that into a single term because I knew that I had a common denominator. Now, I also know that tan squared plus 1 is secant squared. So if I subtracted secant squared and subtracted 1 from both sides, I get tan squared minus secant squared is negative 1. So I'm going to say that this is negative 1 over tan theta. And I know that the reciprocal of tan is cotangent. So my answer is negative cotangent. So with these problems, you guys, I know for some of you, you probably liked this section a lot last year and it came easily to you. For others of you, this may have been a difficult section and you're going to have to definitely put in some time and effort. I cannot stress to you guys, the more or the better that I know those 11 identities, the easier going through these problems becomes.